In this lesson, we're going to learn about two types of angles, so central angles and inscribed angles in circles. The first type of angle is a central angle, and central angles are formed by two intersecting radii, and their vertex is located on the center. So that's where central angles get their name from, is because the vertex is located on the center. And like I said, they're formed by two intersecting radii. Now, the nice thing about central angles is finding their measure is really easy because the measure of a central angle is equal to the measure of its intercepted arc. So one thing to keep in mind when we're talking about the intercepted arc, if you imagine tracing over this angle, let me not use that color, but if I were to trace over this angle, where it's cutting into the circle is called the intercepted arc. So that's important because that is going to be used a lot for these angle problems. So it's where your angle cuts into the circle is the intercepted arc. I recommend highlighting that arc because that is going to really help you a lot with these calculations. So like I said, for central angles, so I'm going to say when the vertex is located on the center, the angle is just equal to the arc. So that's our formula. Very easy to know. So when I look at these scenarios, I look at where's the vertex located. Well, the vertex is located on the center of the circle, which means this central angle, the 120, is cutting into this arc right here. So this arc has to be 120. And then from there, there's two ways that you can think about how to find x. Well, I have a semicircle, so this is a diameter of the circle, so it's splitting the circle into two semicircles, which means this whole thing is 180. So if I know that this part over here is 120, I can just do 180 minus the 120, and that's going to give me 60. So that's my x is equal to 60. That's one option. The other option would have been to say that these two angles are supplementary. So if this angle is 120, well, this angle is 60. Central angles are equal to their intercepted arcs, so that's going to have to be 60 degrees as well. In the next example here, we have, I'm just going to zoom this in so we can actually see what we're looking at. So we have our angle X, which is a central angle. And if we go ahead and highlight that angle to see where the intercepted arc is, it's cutting into this arc right here. So that's the arc that this angle is equal to. So in a circle, the total number of degrees here around the entire circle is 360. So if I do 360, subtract off the 250, that gives me 110 degrees. So that's how many degrees are in this arc, which means that's how many degrees are in the angle, since the angle is equal to the arc. So in this example, x would just equal 110. The next type of angle that you need to know about is called an inscribed angle. And you've heard of inscribed polygons, you've heard of inscribed triangles. Inscribed means that the vertices of the polygon or the triangle is on the circle. So when we talk about an inscribed angle, it means that the vertex is on the circle. So the vertex of this angle, angle B, is on the circle. And the other parts of the angle are formed by two intersecting chords. So you can see that the angle is completely contained in the circle, and the vertices of the angle are actually all on the circle, but mainly this vertex B is what we care about, being on the circle. So for this one, the angle is always equal to half of its intercepted arc. So my intercepted arc is this arc right here. That's the arc that this angle is cutting into, and x is always going to be half of that. So if this is 100, x is going to be 50 degrees. So I'm going to go ahead and highlight that. The measure of an inscribed angle is half the measure of its inscribed or intercepted arc. And what I call these sometimes is on angles, meaning the vertex is located on the circle versus on the center of the circle. So for these on angles, the angle is going to be equal to 1/2 of the arc. So that's the formula you want to remember. So it's inscribed because the vertex is located on the circle. So looking at these examples here, I have my angle that I'm trying to find is x. I look for the vertex. So here's the vertex of the angle. It's on the circle. This angle is completely contained within the circle, making it inscribed. So this on angle is 1/2 of the arc it cuts into. The arc that it cuts into is this 84. So x is equal to 1/2 of 84. I'm going to backtrack for a second here and just say that the angle is equal to 1/2 the arc because we should be writing our formulas down, our substitution, and then we solve it. So 1/2 of 84 is going to give me 42. So that's it. I look at the next one here, same thing. It's an on angle. The vertex is on the circle. So the angle is cutting into this arc, which is x. So my angle is equal to 1/2 the arc. So in this case, the angle is 30. The arc is x. So what I need to do to figure out the arc, well, I'm going to have to double it or multiply both sides by 2. So the arc would have to be 60 degrees. And then the last example here, if we look at what we're trying to find angle x. So the vertex of angle x is on the circle. It's cutting into this arc right here. So if I look at my formula for this, if it's an on angle, the angle is equal to 1/2 of the arc. So that means x is equal to 1/2 of the arc. The problem is I don't know what this arc is, but luckily I have this central angle here. So this central angle has to be equal to the arc. So the central angle equals the arc. So that means that x is 1/2 of 70. So x is equal to 35. And that's it. So basically you have your two formulas. When the vertex is on the circle, the angle is 1/2 of the arc. When the vertex is in the center or on the center of the circle, the angle is equal to the arc. So there's your two formulas. So go ahead and get some key ideas written down and check your understanding problems.